Bismillahirrahmanirrahim. Today is lecture number 10 and the topic name is deployment and scalability. Myself, I am Dr. Muhammad Farooq. Today we are going to learn in detail what is the meaning of this lecture title, that is deployment and scalability. Let us begin the topic. So these are the outlines of today's lecture, like introduction, why are deployment and scalability important, types of deployment, and summary. Okay, these are the topics we are going to discuss. And at the end of the lecture, we shall see the summary, means what we have learned from this topic. First, we shall see the objectives of deployment and scalability in deep learning. First objective is what? Make models available for real world use. Second, ensure model performance and reliability in production. Okay, the primary objective of deployment is to make a trained model and integrate it into a production environment, making it accessible for real-time or batch predictions in practical applications. Example in web services, mobile applications, and embedded systems. Second objective is what? Ensure model performance and reliability in production. Once deployed, it's crucial that the model consistency performs and experiment environment, ensuring reliability and stability. This includes accuracy and robustness while minimizing the downtime or errors. Okay, these 2 points we have seen. This is objectives of development and scalability in deep learning. Second point, third objective is what? Optimize for low latency and high throughput. Scalability ensures that models can handle a high volume of requests or data inputs while maintaining fast response times, low latency, and high processing capacity. Throughput, especially in time-sensitive applications like real-time video analysis or financial predictions, support large-scale data and computation needs. Scalable deployment aims to handle increasing data volume and computational complexity, ensuring that the model can scale seamlessly as application. Okay, this is the fourth point, support large scale data and computational needs. Okay, what is the definition of deep learning, deployment in deep learning? Deployment in deep learning refers to the process of taking a trained model and integrating it into a production environment where it can be used to make prediction or perform tasks in real time or non or on demand. Okay, this is the definition of the deployment in deep learning. Okay, so now what are the key aspects of deployment? Model convergence into deployable formats, integration with production systems, example web servers, mobile applications, ensuring stability, reliability, and performance during interfaces, inferences, handling issues like versions control, updates, and monitoring. Next, definition of the scalability in deep learning. Scalability in deep learning refers to the ability of a system to efficiently handle increased workload, large data sets, or more complex models without a significant drop in performance. Okay, now the key aspects of the scalability. What are the key in this slide? We shall see what are the key aspects of the scalability. Horizontal scalability, distributing workloads across multiple machines or resources. Vertical scalability, adding more computational power. Example, more powerful GPUs to single system. Efficient handling of large datasets and model complexity, maintaining performance, low latency, and high throughput even as demand increases. This is the key aspect of scalability, like horizontal scalability and vertical scalability. Let us see the next slide for this topic. Okay, now this is the introduction to deployment and scalability in deep learning. Deep learning models, once trained, hold immense potential to solve complex problems in real world applications. However, the process of deployment and scalability plays a critical role in transforming these trained models from research experiments to fully functioning real world solutions, ensuring that a model is effectively deployed and scalable success and impact. Okay, this is the big introduction of the development and scalability in deep learning. Okay, now what is deep deployment in deep learning? Deployment refers to the process of taking a trained deep learning model and integrating it into production environment where it can be used to make the predictions or performance tasks in real world time, batch processing, or in response to user interaction. It involves converting models into deployable format, integrating models into production system, example web servers, mobile apps, or embedded devices, ensuring the model performance performs efficiently and accurately in the production environment. In practical applications, deployment may involve different platforms, cloud services, mobile devices, or edge devices with a specific required latency, computational power, and real-time performance. Okay, okay. Now let us see the what is the scalability. What is the scalability in deep learning? Scalability refers to the ability of a deep learning model or system to handle increasing demands, whether refers to ability deep learning models or system handle increasing demands, whether through data volume, computational power, or used load. As the amount of data grows or as more users interact with the system, scalability ensures that the model can handle these changes without significant degradation in performance. This involves handling larger data sets. As data grows, models need to be able to scale to process large amounts of data without compromising performance, scaling computations resources, whether through distributed training or more powerful hardware. Scalability ensures the model can handle more intensive computations needs. Real-time processing scalability ensures that the model on the maintainable latency. Okay, so these are the what is the scalability in the deep learning? Okay, like scalability handling large data sets and scaling computational resources on real-time processing. Okay, Nick, why are deployment and scalability important? These are the point question. Why are the deployment and scalability important? Real world application. Second, performance optimization. Third, business impact. The first one is what real world application. Deployment ensures that deep learning models are usable in the real life applications such as healthcare, finance, retail, autonomous vehicles, etc. It bridges the gap between the research and practical applications. Performance optimization, effective deployment ensure models performance efficiently, minimizing the downtime and maximizing uptime in real world settings. Scalability ensures that these models retain efficient even as the workload increases. Business impact, scalable models allow businesses to extend their operations or each reach enabling more data processing. So these are the points why are the deployment is really important. Real world applications, performance optimizations, business impact. Okay, next point, cost efficiency and continuous improvement. Cost efficiency property in deployed and scalable systems help optimize resources, example computational power, memory and storage, reducing operational cost and improving the cost effectiveness of deep learning applications. Continuous improvement. Once deployed, models can continue to evolve. Scalable systems ensure that updates and retraining can happen continuously. Okay. Now, key challenges in deployment and scalability. What are the challenges? Number one, data management. Handling large scale data efficiently for both training and real time inference is crucial. Proper data pipelines and storage systems are required to scale models effectively. Model efficiency, deploying large complex models in environment with limited resources such as mobile devices or edge devices require model optimization techniques like cloning, quantization, and dissolutions. Infrastructure, ensuring that the infrastructure cloud on premise or hybrid supports scaling across multiple machines or cloud resources resource dynamically based on the demand. Okay, this continuously challenges key challenges latency and throughput. Meeting the speed and performance requirements of the real-time applications while processing large volumes of data or serving many users simultaneously. Okay, Versioning and the updates, managing different versions of models and rolling out updates without disrupting service or losing data integrity. So these were the challenges in deployment and scalability. Okay, types of deployment in the deep learning. What are the different types of deployment in deep learning? Definition: one premise deployment involves running the deep learning models on local servers or machines within an organization's own infrastructure. Key features: control provides full control over hardware, software, security, and data privacy. Infrastructure requires substantial upfront investment in servers, storage, and maintenance. Data privacy suitable for sensitive data as everything is kept within the organization's premises. Challenges: scalability might be limited due to the resource constraints, hardware upgrades, and extensive use cases. Organization with strict data security, frugality requirements, healthcare, finance. Okay, so these are the different types of the deployment in deep learning. Okay, second point is what? Cloud deployment. Definition: cloud deployment involves hosting deep learning models on the cloud platforms like Amazon Web Services, Microsoft Azure, or Google Cloud. Models run on virtual machines or containerized services in the cloud. Key features: scalability. Cloud environments provide easy scaling to meet increased demand by allocating more resources dynamically. Example: adding more GPUs or TPU. Flexibility: cloud services provide a wide range of the tools for model deployment, monitoring, and management. Cost effective: pay as you go pricing models for using resources. Maintenance: cloud providers handles hardware maintenance. Okay, use cases: startups and business that need flexibility and scalability. Applications that demand high availability and low maintenance. Okay, now third point is edge deployment. Definition: each deployment refers to running deep learning models on devices located closer to the data source. Example: smartphones or and information of technology devices. Okay, in Internet of Things devices, drones, or autonomous vehicles rather than relying on remote servers. Key features: low latency, offline capabilities, resource constraints, use cases. Okay, all right. Like low latencies models can provide real-time predictions without the need to send data back and both forth to a server, ideal for the time sensitive applications. Okay, now next point. Now the fourth point is hybrid deployment. Okay, now definition: hybrid deployment combines both cloud and edge computing to achieve the benefits of the both approaches. Data is processed at the edge, but some complex processing and storage occurs in the cloud. Key features: balance resource allocation, flexibility, data synchronization, and use cases. Okay, so this is the fourth point of different types of deployment in deep learning. Next point. Now types of deployment in the deep learning. Fifth point, serverless deployment. Serverless deployment, also known as the function as a service, involves running models on the cloud platform where the cloud provider manages the infrastructures, scaling and execution. Key features: no server management, automatic scaling, cost efficiency. Okay, the sixth point is what model as a service MaaS. Definition: MaaS involves providing pre-trained models or ability to train models through the cloud-based service. User can access these models via APIs to integrate them into their applications without managing the underlying infrastructure. Key features: pre-built model, ease of use, and subscription based. This is the sixth point, the types of the deployment in deep learning. Now, use cases: small businesses or the startups who need deep learning models, example language models, image recognition, and so on. Developers looking to quickly integrate AI into their applications. Now, types of deployment, 7 point, continuous integration and continuous deployment. Definition: CI, that is continuous integration and continuous deployment for machine learning, involves automating the deployment process to enable continuous model updates, monitoring, and integration without manual intervention. Key features: automated pipelines, second, model monitoring and retaining, third, faster iteration. Use case: large organizations that need to update and deploy models regularly, such as recommendation engines or fraud detection system. Applications that need to evolve with changing data patterns like demand forecasting in retail or financial markets. So at the end of this chapter summary, this is the points we have learned in this lecture. Deployment and scalability are critical components for taking deep learning models from research to real world applications. Deployment and scalability ensures that deep learning models are robust, strong, efficient, and ready for the large scale and real world applications. Okay, so this deployment and scalability and the session in the ensuring that deep learning models move beyond experimental phases and serves real world applications. Proper deployment strategies ensure that models are accessible and reliable, while scalability allows them to grow with the data and user, ensuring the long term effectiveness and cost efficiency. Understanding the concept and challenges of the deployment and the scalability is key to successfully integrating deep learning into the practical large scale systems. So this is the choice of development types depends on functions like latency requirements and so on. So these are the things we have learned in these chapters. Okay, so thank you so much. I shall give you all the questions like true or false and multiple choice question and question answers. Okay, so for the true or false also and multiple choice questions also, I will give you with the answers, so it will be good for you for study. Thank you so much.